company. One moment, please. One moment. Line. Hello, Bob. Kilo, Oscar.
DX station on 20. We've got a massive lid fest going on 20. This is one of the better sounding signals, ignoring the band fading into noise. But this is an example of more of what a sideband signal should sound like. Now this station is a bit low. It's on 14.239.86. That's not really important. But listen as I tune down the band. Hear the Donald Duck. The saying is, sideband sounds like Donald Duck when it's off frequency. But what you don't hear is a bunch of IMD. Listen when it comes back. And this is tuning from about 240 down to about 2K. Now this transmitter is a bit wide on the wrong side. It's a very heavy signal in the wrong sideband, up to about 241. So that transmitter is about from my S meter readings and trained ear, is about 1.5 K wide on the wrong side. At about 1.5 kc, his signal starts dropping off several S units. That's a big drop. But this is not one of the worst sideband signals on the air. There are a couple down the band that are just horrifying. The way we check our so-called modulation, and there is no such thing as listening to a transmitter's audio. Transmitters transmit modulation. They do not transmit audio. And anyone on the air asking on a transmitter, how's my audio, is absolutely incompetent. They know nothing about radio. Here's how we check it. Like in the last video, put the finger on the big knob. We don't hear that loud whining tone. We don't hear that loud distortion. Okay, he's gone now. He'll come back. This is SSB emission. I think it's A3. Single sideband suppressed carrier. We're only supposed to have so-called modulation in one sideband, not both. And suppressed carrier, we really shouldn't hear any carrier. What's happening with these clowns with their Heil microphones, which is one of the world's biggest scams in amateur radio, because Bob Heil's selling basically broadcast microphones to hams, which are 10 kc wide, using them on transmitters that should be 2 kc wide, and it's an absolute joke. But when we use amplified mics and equalizers and overdrive the inputs of these radios, especially in sideband, we get severe distortion from intermodulation. Intermodulation is, to put it simply, let's say there are two modulating frequencies on a sideband transmitter, a two-tone. There's 100 cycle and 800. Let's say there's 10 megahertz carrier. The sideband process is not modulation, it's mixing. And I explain and prove that in my Drake TR3 redesign of the balanced mixer videos. What's happening in sideband is unlike AM, where AM is taking a 10 megahertz carrier and varying the carrier amplitude by this amplitude modulated audio signal. So the AM signal, like in a TR3, which takes the modulating audio right to the final screens and actually changes the gain of the final amplifier and causes the power output to go up and down in response to the modulating audio. That's not what's happening in sideband. And what is happening is a mixing process, and this is what leads to this severe distortion that shows up as this extremely loud tone and bleeding over in the wrong sideband. What's happening in sideband is that it is not truly modulation. What happens in sideband with, for example, the traditional two-tone test, let's say 100 and 800 cycles, with a 10 megahertz carrier. In the TR3, it's 9 megahertz, but we're just doing this for discussion's sake. Those signals, those two audio tones and that RF carrier are put into a mixer circuit. A mixer is a nonlinear system. The result of putting that into a nonlinear system is outputting the carrier and the sum and the difference of the carrier plus and minus the modulating frequencies. So in an RF, on a spectrum analyzer, we would see 10 megahertz carrier, 10.001 megahertz, which is plus 100 cycles, and 10.0008, which is 10 megahertz plus 800, and in the opposite sideband space, 10 megahertz minus 100 and minus 800 cycles. This isn't putting out any audio. This shows the idiocy of asking on sideband, how's my audio? There isn't any, because the doubly balanced mixer excludes the original modulating signal and the carrier. So in theory, a balanced mixer only produces the sidebands. But for reference, this is the center frequency or the carrier. This is a form of frequency modulation. It is not true FM, where the amplitude modulating signal causes the carrier itself to shift like this. But it is a sort of frequency modulation where the modulating tones cause a shift in frequency. There are also amplitude changes, but it's much more important to think of it in terms of frequency. What happens when these mixers get overdriven by these clowns running power mics and equalizers and screwing up their mic inputs is that intermodulation products occur. And let's just for simplicity's sake say that a proper transmitter is doing this. The balanced mixer eliminates the carrier and the sideband filter cuts these two out. So we just get these 10.0001, 10.008 RF components, which represent the original modulation, this original two-tone. Those modulating signals can also mix together in the mixer and create, let's say, 100, 800, and a spurious at 900. That's just with two tones. Put a complex modulating wave in, and you get a whole bunch of crap out that are just polluting this sideband full of trash that is not the original modulation. It's the frequencies in this also beating together, to put it simply, and making basically another kind of, to be very crude about it, another modulating envelope which is not intelligible. That's putting it very simply. The math behind it and the process is much more complicated than that. But this kind of process is what leads to hearing this loud tone, which is often louder than the modulation up here in the so-called intended sideband. But what's happening is that these clowns are overdriving their rigs and they're taking up 2 kilohertz, maybe more, in the wrong sideband. So they're transmitting double sideband, and one sideband is completely nothing but trash. The only thing they're not totally blanking up is they're not transmitting a carrier, but they might as well. Because now, instead of transmitting 100 watts on 100 and 800, they're transmitting it on this frequency, that frequency, that frequency, these down here. They're spreading that 100 watts out over a wider bandwidth, and that is what's known as GBP, gain bandwidth product. For a fixed amount of power, putting that power over a wider spectrum gives the appearance that the signal is weaker. It's also more complicated than that, but on the air, that's what it ends up being. And that's why these clowns with these overdriven microphones and equalizers and driving these solid-state rigs, which, by the way, put that into an A to D converter, and the A to D converter just pukes. This is an analog mixing modulation system. Put this into an A to D converter, and it will throw up all over the inside of the radio when you do this. Then these clowns wonder why they got to have linear amplifiers to be heard 3 states away in the U.S. on 40 meters. So now they're amplifying this garbage and spreading amplified garbage all over the band. In the process, they are violating several US FCC regulations. Number 1, not using good amateur practice, and Part 95 specifies that. Good amateur practice And that rig right there with me operating is about 1.8 kilohertz. And I got no problem with that radio absolutely stomping on pileups. And they can't figure out why. Because I'm not doing this. I'm not wasting my transmit power by overdriving it. This TR3 I've re-engineered with my voice is somewhere between 11 and 1700 up in the desired sideband and closer to almost 500 in the opposite direction. So basically speaking, this TR3 is even narrower than this fancy Yaesu. It's also a lot cleaner because it's tubes. I don't know the bandwidth of the Kenwood, but it's getting better reports on the air than either of them because it has a good processor. And I know how to simply talk in the mic and adjust the mic gain so that the ALC doesn't go over the top of the range, and that's all there is to it. But these clowns with these fancy $1,000, $2,000, $3,000 radios cannot figure out how to plug in a stock mic and adjust the mic gain. They're more brain dead than CB radio operators. I've known CBers more competent than 3/4 of the hams here on 20 meters on phone. It's an absolute disgrace. And in the U.S., it is a violation of not adhering to good amateur practice. It's a violation of being in, what's it called? Not the class, but the designator. I think it's A3 for single sideband. They're not authorized. We're not allowed to use 2 sideband spaces. That's not using the correct module. That's not the correct emission type. It's violating technical standards for exceeding occupied bandwidth. We're only allowed 1 sideband space, and traditionally that's given in amateur radio to breed 3 kc. And what it ends up being is generally 2 up and 1 kc down. Now it's really difficult to get a transmitter with filtering so narrow that there's nothing in the wrong sideband, but it should be minimal. On my transmitters here, the TR3 is only, I checked on a receiver here as best I could, but it's closer to 500 hertz in the undesired sideband. The average transmitter you find on the air is going to be, if it's operating correctly, it's going to be about 2 kc up and 1 kc down, about 3 wide. But these clowns with their audio processing and their high-on mics and their power mics are 5 kc wide, and that is a violation of FCC technical rules. And folks, this is not CB radio. It's not a joke. It's not playtime. This is an engineering radio service, and FCC has the authority to fine these clowns $10,000 per occurrence, which means they could fine these clowns up to $10,000 per occurrence every time these clowns key the microphone and speak. Because every time they do, they are violating FCC regulations. Again, this is not a joke. This is not CB radio. FCC can levy NALs and ask a court to put people in prison for violating amateur regulations. This is not a joke. And they have done so for gross violation. We're also expected in the amateur service to have enough technical knowledge to be able to, before going on the air, decide if our transmitters are working correctly. It is unforgivable to engage in this stupidity on the air of getting on the air and asking somebody else, how's my audio? Most of us have more than 1 rig. Can't we put a transmitter on a dummy load and listen in another receiver, maybe across the room with a piece of shorted coax, and pick up the signal and just put our finger on the big knob and tune up and down and listen? Because that's what I do. I've tested the Drake on the Yaesu and listened to see how pure the Drake signal is. Now, in the context of checking the transmitter's output, which may or may not properly be termed modulation, there's a piece of test equipment called a modulation analyzer, and they are horribly expensive. A spectrum analyzer might be a couple thousand. A modulation analyzer might be 10 or 20. It's really kind of beyond amateur radio to afford modulation analyzers. That's what the receiver's for. It's not going to give us a computer readout, but if we've had some experience on the air and listening to various signals, especially hearing some sideband signals that are proper, We'll pretty quickly learn what a proper sounding signal sounds like. And there's a signal that sounds like crap. Hear the whining tone? Here's a piece of crap transmitter. Hear the whining? That transmitter is spending power to produce that spurious whining tone that is not being recovered as useful modulation by the receiver. It's garbage. But just listen on the band. You'll quickly learn what's a good signal and what isn't. And you'll universally find that it's not these new transmitters. I worked a couple nights ago, CO2CO, Azores. Absolutely blew his blanking doors off. 5'9 plus 20. He was 5'6 in Azores. Not terribly far. On the Kenwood. He gave me a report of 20 over, and he said, "What in the world kind of radio do you have? It sounds incredible. What kind of mic?" He starts this "what kind of mic" crap with me. I said, "No, Mike. It's just a plain Elenco stock mic. It's too hot, so I turned the mic gain down. It's just a stock transmitter." "I can't believe how clean your signal is." "Yes, that's because I haven't effed it up with an equalizer and a power mic and a high-end microphone. I'm a real ham and an engineer that can design that radio. And I know that microphone is much too hot for this rig, so I turned the blank and mic gain down." We don't get any further out. In fact, we get less distance by cranking the mic up and shouting in it, like somehow they're going to hear us better if we can shout through the walls. Again, I've known CB radio operators that are much more competent than 3/4 of these clowns on phone and the amateur radio service. U.S. and international both. It's an absolute disgrace. Let's see if ON6 can hear me. Kilo 8 Bravo Yankee Papa.
Ending Papa.
Yeah, you heard me. Kilo 8 Bravo Yankee Papa.
Kilo 8 Bravo Yankee Papa. Thank you for coming back to my call. Good morning. That is your 5 and 7, 57 in Belgium. My name is Piero Papa in the Echo Radio. Kilo 8 Bravo Yankee Papa. Oscar November 6 Mike.
Thank you, Piero. This is Dave, Delta Alpha Victor Echo in Tennessee, Tango November. Also about a 5.6, 5.7 with QSB. Transmitter sounds good, over.
Thank you for the 5 and 6 to 7 in Tennessee. Thank you for the contact there.
That's a proper sounding sideband transmitter. Hear the Donald Duck? 73, old man. Thanks for the DX. KBYP did it. He had no trouble whatsoever hearing me with this stock Kenwood max of 95 watts. Watch ALC. K8BYP test. K8BYP testing. That's on the air. Mic gain turned down on this mic that's way too hot. This is mic from an Elenco VHF UHF transmitter. It just happens to work on a Kenwood. When the mic's too hot, turn the mic gain down so it's within the ALC window. That's what the function's for. ALC is automatic level control, but it can only do so much. It can't fix stupidity. It only has a limited range. It's possible to grossly overdrive it. So we got to be intelligent here and be on top of this thing. Else, this ain't CB radio, folks. We're violating FCC regulations, and they can nail us. Again, not fun and games, and not a communications radio service. FCC says this is an engineering and technical radio service, and we are required to know both Part 95 and Part 15 regulations and have properly operating transmitters. I do, and with barefoot radios, I stomp on pile-ups, and they can't figure out why. Lesson learned. Turn the bloody mic gain down. If conditions are so bad nobody can hear you, being distorted ain't going to help. Turn the radio off, find something useful to do. If they still can't hear you, get rid of the junk antenna and build a proper antenna. Lots of info on that on my YouTube site. KBYP out.